Welcome to Introduction to Programming. In this section, we're going to have a short introduction. We will discuss hardware and software, and we will talk about how computers store data. You must have hardware and software in order for your PC to work properly. Hardware is the physical devices that make up a computer. The typical major components of hardware are the central processing unit, main memory, secondary storage devices, and input and output devices. The central processing unit, or CPU, is the part of the computer that actually runs the programs. Sometimes you may actually hear it being referred to as the brain of the computer. Microprocessors are CPUs that are located on small chips. Main memory is the memory that the computer uses to run applications. It is also known as random access memory. Now, the CPU will quickly access the data that is located in that random access memory. Random access memory is also volatile memory because it's used for temporary storage. So what that really means is it'll be running while you are running the program, but when everything is shut off, you're going to lose all of that memory. And that's why if the PC or the power accidentally goes off, you lose everything that you've been typing on that paper. Secondary storage devices are a little bit different than main memory, and that secondary storage can hold data for very long periods of time. So examples of that would be the hard disk drive that are in your computer. The hard disk drive that's typically in there may work magnetically and have a spinning circular disk inside of it. The solid state drive is very similar, but it is faster than a disk drive and there's no moving parts, and it stores data in a solid state memory. It's also a little bit more expensive of a drive than the standard disk drive. Another example of a secondary storage device might be your flash memory or an optical device. A flash memory is portable. It's very small. You can put it on your keychain or put it in your pocket. Most of you should be familiar with flash memory. Optical device is like your CD-ROM or a DVD, and data is encoded on that optically. Another device on your computer are input devices. Now, input is any kind of data the computer collects from users or other devices. So really what that means is anything that I put into the computer as a user is an input. So if I use a camera and I am recording a video or something like that, then I am creating input. If I am using a mouse to click on things, to go from one web page to another, or to do any type of productive work, then I am putting in input. If I scan something into the computer, then that's input as well. The keyboard is also another example of an input device. Right now, I'm creating input because I'm recording my voice. The technical definition for an output device is data produced by the computer for users or devices. But as a user, from that perspective, is anything that you see on a screen, anything that you print out on your printer, anything that is in a readable format that you can see is an output device. So let's talk about software. Everything on the computer is controlled by software. Two software examples are application software and system software. Application software is any program that any person can use on pretty much any computer. So an example of that would be if you're browsing the internet, if you're checking your email, playing games, which, you know, being geeks, we don't play games, do we? Writing a letter in word processing, or even creating a spreadsheet. System software is a little bit different than application software in that we don't necessarily, as a user, really see all the system softwares. I mean, for example, operating system is a good example of a system software. We see it, we interact with it, but we don't really think that much about the operating system. A utility program such as a printer maintenance software might be another example. Those we do see, we play with. Some people may not realize so much that they're there, but sometimes we need to use it to clean the ink, run the maintenance program on an inkjet printer, for example, and clean up all the inks on the nozzles. Software development tools are another example of system software. And those types of tools are used to write programs, which is what we're going to be doing one of these days. When learning to program, it's really important to learn about how computers store data. Now, this is something that's going to take a little bit of time to get down. It's going to take some practice to get down, and you may not even really fully understand how computers store data until you've played with it quite a bit. But the computer is definitely going to only read data that is stored in zeros and ones. Of course, as the user, we don't see the 0 and 1s, but the computer translates it so that it can understand all the zeros and ones so it can process instructions. So a byte is a size of memory store is just big enough to store a letter or a small number. Now, this type of information will be important when you're writing programs because you'll need to know what type of data to tell your program compiler so that it knows exactly what to process, and also so that you know how much space you are taking up. So in the last slide, we talked about how much space a byte takes up. A byte is actually 8 bits as well, and a bit is an electrical component that can hold a positive or negative charge, like an on or off switch. That's kind of how the computer translates everything. It puts it into binary, and then it reads whether or not it's a 0 or 1 based on whether or not an electric current is present. The on and off pattern of bits represent the data that the computer is going to process. So remember, a bit represents two values, a 0 or a 1. Computers can use the binary number systems, and byte size limits are 0 and 255. So if a byte is all 0, then that means all bits are off. If it's 255, then all bits are on. So let's say it one more time. Data stored in the computer must be stored in binary. Characters are converted to numeric code, and the numeric code is also stored in binary. Now, there are two types of numeric codes. There is the ASCII and the Unicode. ASCII is limited to 128 characters, and Unicode is actually supports multiple languages. Advanced number storage deals with negative numbers and real numbers. So negative numbers are encoded using a 2's complement, and real numbers are encoded using floating point notation. Now we'll talk about how to tell the compiler what you're going to use, whether you're having floating point notation, 2's complement, or however you're going to do anything later on in the class. But it's just important to know that, again, telling the compiler what type of number that you're using is extremely important when you're designating it, because of the space that it takes and because it knows how to process that particular type of data. Ta-da! Now you finished lesson 1. Let's move on to lesson 2 and let's learn how a program works.